Hey, hello, my name is Solo Ange and welcome to my channel. Alright, I hope you're having a good time because it's good to have a good time when learning math, especially, right? Good. Okay, so here we want to find the nth term of this sequence. So the sequence is -3, the second term is 9, the third term is 29, 57, 93, and so on and so forth. Good. So of course, whenever you want to find the nth term of any sequence, you want to find out what the pattern is. Okay, so this looks like it should be an AP, of course. Let's see, this is 9 minus -3, that's 12, okay? But if you add 12 to 9, well, we don't get 20, we get 21. So this doesn't follow a linear sequence. So what do we do? Well, GP, it doesn't follow as well. Okay, if you square -3, you get 9, but if you square 9, you don't get 29. Okay, or maybe you multiply 9 by 3, oh, you don't get 29, rather you get 27, or minus 27 if you like. So it doesn't work. So what do we do? All right, so what do we do? Well, one of the things I do whenever I'm given some sort of sequence of numbers, okay, one of the methods or one of the things I try is to just find the difference between any two consecutive terms. All right, so this is what I mean. So you look at that the first term is 3, the second term is 9. What I will do is that I will say the second term minus the first term. Okay, see what I will get. In this case, it's going to give us just 12. Good. So we now say, okay, the third term minus the second term. Okay, we notice that in this case, it will give us 20. That's 29 minus 9. Then the fourth term, which is 57, minus the third term, which is 29. If you do that difference, you're going to have 28. Good. Okay, maybe let's do this one. The fifth term minus the fourth term. Well, what we notice there is that you're going to have well, 93 minus 57, that should give us 36. Okay, great. So you notice that this difference, right, the difference between any two consecutive terms gives us some sort of AP. Okay, you can notice that the difference they increase by a constant, and the constant is 8. All right. Great. So that is a very good observation. That means though our original sequence is not an AP, but the difference, the sequence of the difference between any two consecutive terms forms an AP, where the common difference of that AP is 8. So maybe I would just like to write out the sequence in this way. So let's just write out the sequence formed from the difference, right, as D, and the first term is that 12, right? So the second term in that new sequence is 20. We have here 28, we have here 36, and maybe you can continue like that by just adding 8, right? So that should be 44, so on. Great. Okay, so how will this help us? Well, let's go back to this again. So you notice that to find T2, we will need to add 12 to T1, right? So I'll just say for the first term you add 12 to it, that will generate the second term. That's just from this first equation. Great. So for the third term, well, how do you form that from the first term? So you notice that from this equation, the third term will be 20 plus the second term. But the second term is already this, so we're going to replace this for the second term. That is the second term, T1 plus 12, and then we're going to add 20 to that. Good. That is this 20, all right? And then for the fourth term, we'll do a similar thing. The fourth term should be the third term plus 28. So but the third term is the whole of this, so that will be T1 plus 12 plus 20 plus 28. That's the fourth term, and then the fifth term follows suit. So we have T1 plus 12 plus 20, all right, plus 20 plus 28, then plus 36. Great. Okay, so we make the following observation. So you notice that to find any term from the original sequence, that is the first term, no, sorry, it's from the second term, okay, the third term, fourth term, fifth term. Notice what we've done. For the second term, we only took the first term of the new sequence, that is the new AP, all right, or the AP that we just discovered. Then for the third term of the original sequence, we had to add the first two terms of our AP to T1 from the first term. Then for the fourth term, we had to add the first 3. For the fifth term, we had to add the first 4. So, okay, so using that, we can easily generalize by saying, okay, for any term of our original sequence, okay, we're going to have to add the first n minus 1 terms, because for the fifth term here, we had to add the first 4 terms of this new sequence, which is actually an AP. So we're going to take the first n minus 1 terms, added it to T1. So I'm going to just write here T1 plus the sum of the first n minus 1 terms of our new sequence. All right, so let me just write the sum of the sequence D, which is this one, and it should be n minus 1. That means the sum of the first n minus 1 terms of our new sequence. Good. So let's see what that sum will give us. Then we'll come back to this equation. So this is a very important one. So maybe let's just keep it somewhere. All right, we'll come back to this equation. So let's deal with the sum of the first n minus 1 terms of this sequence. Good. So how do we find the sum of the first n minus 1 terms of this sequence? Well, we use our normal formula for finding sum of n terms of an AP, because this is actually an AP. And in the real sense, this actually gives us the sum to be n over 2. Okay, we are looking for the n terms, right? Into 2 times a plus, we have n minus 1 times their common difference. That is 4. Yeah, oh, sorry. Okay, so that's what we use. So in this case, we have some little differences. We are not looking for the sum of the first n terms, but rather the sum of the first n minus 1 times. So in place of n, I'm going to be putting n minus 1 every time, right? Divided by 2. Multiply it by 2 times a. Well, our a here is 12, so we double that. That will just give us 24. Then we add, well, n minus 1. So in this case, it's already n minus 1. When we subtract 1 from it, we're going to have n minus 2. Okay? And then, don't mind that. That's just n. Then our common difference here is 8. Good. So let's do this work on that. So I'm going to maintain what I have out here. So this is 24 minus 16. Okay. 24 minus 16, that's just 8. Then plus 8n. Maybe we can divide things out a little bit. Minus 8n. Okay. So we divide this by 2. We're going to have n minus 1 times 4n plus 4. When we cancel, or we factor out the 2, right? To cancel out with these 2. Good. So maybe let's just expand these 2 brackets. We're going to have 4n squared. Okay. 4n squared like that. Then this is 4n minus 4n, that's 0. And then negative 4. So maybe let me just put minus 4 like that. Good. This is the sum of the first n minus 1 terms of the new sequence, which was formed from the differences, or from the difference of consecutive terms of our original sequence. Good. Okay, so this is what we have. So to find the original term, we need to come back to this equation, which means we're going to have Tn to be, well, that will just give us T1 plus that result. So T1, remember T1 here means the first term of our original sequence, which was minus 3. Okay, it was minus 3. So we're going to use that right here. That will be T1, that's minus 3, plus this, which is that result. So maybe let me just do that at once. So we're going to have 4n squared minus 4 minus 3, that's minus 7. This is our result. This result should be able to give us what we want. That is to say, it should be able to give us any term from the original sequence. So maybe let's check it out. So I'm just going to write out here 4n minus 7. Sorry, 4n squared minus 7. So let's test. When n is 1, what happens? We're going to have 4 minus 7, which is negative 3. Okay, when n is 2, 2 squared is 4, times 4, 16. 16 minus 7 is 9. That works, right? Then when n is 3, 3 squared is 9, times 4, 36. 36 minus 7 gives us 29. So that works as well, right? When n is 4, 4 squared is 16, times 4, 64. 64 minus 7, well, that's 57. When n is 5, 5 squared is 25. 25 times 4 is 100. 100 minus 7 is 93. That works as well. Good. So it seems as if we have what we actually wanted. And in fact, it's really, really interesting to know that, right? So this is the result. Now you notice that this result is a quadratic sequence, right? So if we were to have a kind of a function that for any natural number, any natural input, it will generate a result for us. This will be the function. Okay, so actually there's a very standard way of doing this kind of stuff. I wanted to just make use of AP, all right, to show you that to generate some quadratic, we kind of depend on linear relationship. And that happens at the second step. By second step, I mean when you take the difference of consecutive terms, you don't expect to have a common difference, but rather you expect to generate an AP. That shows you like a second step, which brings about the quadratic sequence, right? So if you were to take the difference of the first consecutive terms of the first sequence, and it gave us a new term, a new sequence, and then you now take the difference between consecutive terms of that new sequence, and you now have a new sequence of an AP, then that should be like cubic, right? Power 3. Good. Okay, so using that result, how can we, without using this method, how can we just find this kind of problem? Or maybe if we want to generalize, right? We want to have the general result for any sequence that has this form. Okay, what should we do? Well, I did a couple of stuff and I played around with it, and I observed that this would be the solution where the coefficient of any square, all right, will be half of the common difference of the new sequence, and it works. For example, the common difference of our new sequence was 8, all right? Then half of 8 gave us 4. That is why that's why we had 4, and this is the general result, half of the common difference. Anyway, I'm going to do that. I've made a video of the generalized form, all right, of that is the general result when you have a sequence that follows a quadratic sequence in the channel. So please just check that out in the channel. I hope you enjoyed the video. I hope you're able to learn this simple method. Like I said, there's a standard way, and that standard way you can just check it out. It's just by writing something like this, say fn is, since you don't know what the coefficient is, but you know it's a quadratic, so you can always do something like this, and then something like that. This is quadratic. Then the m is to find what a, b, and c's are, right? You can just put 1 in place of n, which means the first term. You equate it to the first term of the original sequence, which is -3. Then you now put in 2. Okay, if you are able to do that 3 times, you'll be able to generate a result for the original function by finding the constant a, b, and c. Anyway, thanks for watching. I hope you enjoyed the video. Please check out our channel for a general way of getting this thing done real quick. Alright, I hope if you enjoyed the video, please don't forget to subscribe to my channel and share this video with your friends. Goodbye.